So now I'm going to talk about some of the rules of integration, especially constants. So this is something that's really almost like skipped over in books or in textbooks. Like the one I read, there was only one line dedicated to it. It's actually a really important idea, and it can be a bit confusing, but I'm going to try and explain the way that makes a bit more sense. So here I've just said constants are taken out and they don't influence the behavior of the function as they're not linked to the changing parameter. And that's a lot of big words. So let's do an example here. I say, okay, so take this car. The car's mass is going to be constant, so it's not going to change over time, all right? So you leave your car in the morning and then get in at night, it'll weigh the same, have the same mass. So if you had a function that tested, say, the braking function, I've made this function up, this is bad physics, it's just for the example here. So this braking function is dependent on the speed and mass of a car, right? The mass of the car would be the same for every speed. So it's dependent on the two, but only one of them is going to be changing. So this braking function, what we'd want to figure out is it's going to be the integral of the mass of the car times the speed of the car. Well, what we can figure out now is actually that the mass is always going to be the same. So we can actually think about not having to integrate it, okay? So we were integrating this with respect to time, so ds in seconds. So now we can take this out. So this doesn't have any time component in it. This is a constant. So let's not even worry about it. And we just focus on integrating the parts that do have a time component in it. So we're left with this. So a braking function is going to be equal to mass times distance. Now, the physics of this doesn't work, but my point being is that you can see that this mass part here had nothing to do with the thing that was changing. So we could take it out front, right? So yeah. So in kind of notation, if you had something like this, the integral of ax to the power of n dx is equal to a multiplied by the integral of x to the n dx, right? So you can take it out. You can take it out of the function. You don't have to worry about it. So this really can help simplify a lot of problems. So any kind of like integers, any numbers at the front, you can take them out. So I hope that makes sense now. Just think about it like that. Only worry about the things that have the same letter as the dx. So if this is t, dt, etc., etc.